There's a trick on the AP Chem exam that lets you solve word problems you don't even understand. In the next few minutes, I'm going to teach you a technique that can be applied to more questions on the AP exam than any other single application. Imagine for a second, you're in the middle of taking the AP exam, your adrenaline's up, you're worried about finishing on time, and you definitely didn't sleep long enough last night. Then you see this word problem spanning half the page, and as you start to read it, you realize you have absolutely no idea what it says. Maybe you panic. Maybe you start to give up, accepting that you're never going to pass. Then you notice something. The problem's given you 2 or 3 numbers, each with their own units, and it's asking you to calculate some strange variable that could be Greek or hieroglyphics for all you know, but it also provided the units. Then you remember this video. All right, that was way over dramatic. But seriously, here's the thing nobody tells you about the AP Chem exam. Most of the exam uses a finite number of tools that are applied in different ways and in different combinations. What I'm about to teach you is the most commonly applied tool on the AP exam. Let's dive in. We'll start with eggs. How many eggs are in a dozen? Hopefully you said 12, otherwise we have bigger problems. All right, 12 eggs in a dozen. How many eggs are in 3 dozen? 36. Let's try that a different way. 24 eggs is how many dozen? 2 dozen. Great. What does this have to do with chemistry? Each one of these was a conversion from one unit to another, and conversions are all over the AP exam. Unfortunately, they're not going to be applied to eggs and dozens. Dimensional analysis is a process that allows you to accurately perform even the most complicated conversions. It utilizes equivalent statements that get adapted into conversion factors. Keep in mind, there are no write the definition of blah, blah, blah questions on the AP exam, so understand the concepts I'm introducing. Don't bother memorizing definitions. An equivalent statement sets one measurement equal to another. For instance, 1 foot equals 12 inches, there's 60 seconds in a minute, and of course, 1 dozen equals 12 eggs. A conversion factor is a fraction built from an equivalent statement. By putting one half of the equivalent statement on top of the fraction and the other on the bottom, you get a fraction that's equal to 1 and that can be used to convert between units. Every equivalent statement gives you a pair of conversion factors depending upon where you put each component. Now that you understand the pieces, let's put the whole process together. In the first conversion, we established that 3 dozen is equal to 36 eggs. To perform dimensional analysis, start by writing out the number, units, and substance given. In this case, 3 dozen eggs. Then, this number will be multiplied by a conversion factor. I'm going to just draw a line from my fraction so I can build from there. When writing the conversion factor, always start with the units. Ignore the numbers and focus on changing from one unit to another. The unit I'm trying to change is dozen. In order to change this, I'm going to put the dozen in the denominator. If I divide dozens by dozens, they'll cancel each other out. The unit I'm looking for goes in the numerator. In this case, I'm trying to solve for eggs. Now that I've written the units into my conversion factor, I can match the numbers from the equivalent statement with the units I just put in the fraction. That's helpful. 1 goes next to the dozen in the denominator, and 12 goes next to the eggs in the numerator. That simple matching step shows you the math required to perform the conversion. Now, the calculation. Take the number in the front, multiply it by the number in the numerator, and divide by what's in the denominator. 3 times 12 is 36. I know what you're thinking. Why do I need that whole process when I already knew there were 36 eggs in a dozen? Because as long as you know the equivalent statement, you can convert between anything using this process, even if you have no idea what the units are measuring. Let's start with the actual chemistry, and I think you'll understand why this is useful. The most common application of this conversion is between grams and moles. However, you'll be expected to know how to find the equivalent statements for the conversions on your own. When in doubt, go to the periodic table. Within each element block, there's an integer on the top and a decimal on the bottom. The number on the top is the atomic number. It's the number of protons in an atom of that element, and the decimal on the bottom is most commonly referred to as the molar mass and is measured in grams per mole. When referred to as the atomic mass, it's got the same numerical value, but it's measured in different units. The molar mass is the mass of 1 mole of the element in the box. That means that 1 mole of carbon has a mass of 12.01 grams, or 1 mole of carbon is equal to 12.01 grams. It's the equivalent statement for converting between grams and mole. Every decimal at the bottom of each box on the periodic table is secretly an equivalent statement, which means that these are the magic numbers for converting between grams and mole. And in every case, the number is the grams in 1 mole. So the 1 always goes next to the mole when put into the conversion factor. Let's apply that now so I can show you. This first question gives the moles of carbon and asks for that measurement to be converted to grams. The equivalent statement is already up, and I'm going to put my process on the right side of the screen. Most mistakes are made because students skip steps or immediately reach for their calculator. Laying out a standard procedure to follow eliminates errors. If you really want to get a 5, develop the habit of following correct procedures and not rushing through your work. There's plenty of time if you're well practiced. First, I write the number, units, and the substance. Quick note, the abbreviation for moles is MOL. M is for meters, and yes, symbols matter. First thing I'm going to do is draw the fraction bar for the conversion factor. And as much as I want to be lazy and just throw numbers into this thing, I'm going to start with the units. I have moles. I want grams, so that goes in the top. I'm going to remind myself that the molar mass is the grams of 1 mole. So for these conversions, the 1 always goes next to the mole. Then the mass, 12.01, goes next to the G. To calculate, 0.35 times 12.01 gives me 4.2035 and change. I'm going to write down a few extra digits. I call them guard digits. The 0.35 given in the problem is only 2 sig figs because leading zeros don't count. So I don't need everything my calculator spits out, just a few guard digits so I round correctly at the end. By the way, the 1 in the denominator is an exact number, so it has an infinite number of significant figures. Your answers will never have 1 sig fig, and they definitely shouldn't have an infinite number of sig figs. 4.2035 rounded to 2 sig figs is 4.2. I'm labeling that grams of carbon because the work I did converted the moles of carbon into the grams of carbon. Now, double check the question to make sure that that matches. Calculate the mass of carbon. Good. All right, I found what the question was asking for. It only takes a second to double check that what you found matches what the question is asking for. Take the time to do this and you'll be more accurate. Another good habit is to circle your final answer. I've been doing conversions like this for 30 years and I still take the time to think through the dimensional analysis process because it guarantees a correct answer every time. A huge part of why students earn 5s on the AP exam is because those students build the systems that guarantee correct answers, and they begin building those systems from day 1. Question 2 runs the conversion in the other direction, and this is where you'll recognize whether you've memorized things or you actually understand how this process works. Don't wait for me, follow the steps and try this one. I'm starting with 54.3 grams of calcium, write that and the fraction bar. I have grams, so that goes on the bottom, but I'm looking for moles on the top. The molar mass is the grams per mole, so the 1 goes next to the mole every time. Calcium's molar mass is 40.08. That goes next to the grams on the bottom. Now the math. 54.3 times 1 is itself, so I plug in 54.3 divided by 40.08. That gives me 1.3298 and some other digits I don't need to write down. My inputs have 3 and 4 sig figs, so my answer should be rounded to 3. That gives me 1.33. Wait, remember to confirm that what you found matches what the question is asking for. Let me go back through my own work. I canceled out the grams to find moles, and I didn't change the substance, so I found moles of Ca. Is that what the question was asking for? Yes, it was. Check your work and the question. Students often lose points because they perform a calculation correctly, but solve for the wrong thing. Check both every single time. 1.33 moles of Ca is the correct answer. Now, This gets more interesting when you're working with a molecule instead of a single atom. This adds an extra step to an existing problem, combining different processes together. This is a skill you're going to use throughout AP Chem and on the exam, as different aspects of the material are combined together into more complex multi-step problems. Start developing that skill here, and you'll be better prepared when this is applied to more complex material later in the course. Carbon and calcium are atoms. Although they contain protons, neutrons, and electrons, they're considered a singular substance as far as both the diagrams we're looking at and this type of conversion is concerned. Molecules contain more than one atom. They can be a single element, like oxygen, or comprised of different elements such as water and carbon dioxide. A molecule containing different elements is referred to as a compound. The important thing here is that each of these is made up of multiple atoms. When converting between grams and moles for a molecule, you'll use the molar mass of the full substance. The molar mass of each molecule is just the sum of the constituent elements. O2 is 2 oxygen atoms, H2O is 2 hydrogens and an oxygen, and CO2 is 2 oxygens and a carbon atom. Just sub in the molar masses for each element and then plug that into your calculator. And you'll have the conversion factor that you need to apply to that problem. Let's do a slightly more complicated molar mass calculation before I combine this with the dimensional analysis. Pause the video and try this one. I'll put the solution up in a second. When you have parentheses, be careful with your math. You can separate things the way that I did on the first line to highlight the 2 NO3s, or you can just multiply all subscripts carefully to create what I did in the second line. I wrote this one because students typically miscount oxygens in questions like this. Also, remember that you're required to show your work on the AP free response. Your habits in practice are going to dictate your habits on the exam. Start building good habits now. The last line here would be sufficient evidence of your work. You don't have to write down everything that I did on the screen. Now, let's combine this calculation with the dimensional analysis and see if we can keep everything straight. Take one question at a time. First, calculate the molar mass, then use that number to perform the conversion. Starting with number 4. CH4 is comprised of 1 carbon and 4 hydrogen. Don't round because this is not the end of the problem. I'm given 1.384 moles of CH4. Put in the fraction bar. I have moles on the bottom. I want grams on top. Molar mass is the grams in 1 mole. 1 goes next to the mole every time. And from above, 16.042 goes next to the G. Plug in 1.384 times 16.042, and I get 22.2021, including a few guard digits. My inputs here have 4 and 5 sig figs, so I want 4, 22.20. Check my work. I found the grams of CH4, and yep, that's what the question asked me for, so circle it. Done. Next one. Let me clear out number 4 so I have a little room to work. Ammonium oxide has 2 nitrogens, 4 times 2 is 8 hydrogens, and 1 oxygen. Plug in the molar masses and don't round. Starting with 0.25 grams of this thing, fraction bar. In this case, I have grams, that goes on the bottom. I want moles. The 1 always goes next to the moles. 52.084 goes next to the grams. So 0.25 divided by, since it's in the bottom, 52.084 equals this thing. 0.25 is only 2 sig figs. Leading zeros don't count. And you could go either way here, but once I have this many zeros after the decimal, I like putting these in scientific notation. Now let me double check. My work shows that I converted the grams to moles, and that is what the problem told me to do. Have you noticed the way I think through every step the same way each time? Drill these procedures and they'll guarantee you find the correct answer 100% of the time. Next, I have a challenge for you. Most chem teachers hand you a test with problems that look like the ones you just practiced. The AP exam doesn't. It expects you to take the tools you've learned and apply them to things you've never seen before. See if you can do that now. Follow the process and solve the problem. Here's how to do it. I'm given that many moles of Na3PO4. Put put it in the fraction bar. This problem gives me moles. We put that on the bottom, and it's looking for molecules, even though we haven't looked for that before. Avogadro's number, as given on the top, is the molecules per mole. So the 1 goes next to the mole on the bottom, and 6.022 times 10 to the 23rd goes on the top. We plug in 0.683 times 6.022 E23. Yes, I said E here because your calculator has a scientific notation button that will make it much easier to perform calculations like this. Make sure you know how to use that button properly. If you haven't been taught about that and would like an additional video on what I call the magic button, or anything else for that matter, please let me know in the comments below. That gives me this. Don't forget to write down the scientific notation on the end of this number, learn how it's presented on your calculator, and include it, otherwise you're wrong. Rounding, the 0.683 has a leading zero, so that's only 3 sig figs, while 6.022 is 4. Also, feel free to let me know down below if you'd like a sig fig video. My final answer is 4.11 times 10 to the 23rd molecules of Na3PO4. That's what I found and what was asked for. Nice. Well done. But I still have another challenge for you. Here's a hint. Every question in this video required a single-step dimensional analysis conversion. This one takes 2. Give it a try. There will be multi-step dimensional analysis questions on the AP exam. A fundamental tenet of problem-solving efficiency is to combine like tasks. If your brain has to jump back and forth between units and numbers and calculations too many times, you're more likely to make a mistake somewhere. I'm going to start by developing a plan for setting up my conversion, then I'm going to work through each mental process one at a time. Watch how I do this. I'm given the liters of methane, CH4, and asked to find the moles. Density is the new thing here. The units on it are grams per liter. That indicates that I can rewrite this as this equivalent statement. Ooh, that means I can use density to convert from liters to grams. That'll be my first step. Once I have grams, I can use the molar mass of CH4 to convert into moles. Capital MM is the standard abbreviation for molar mass, by the way. You're not actually required to write down this map, but you should be at least thinking through your process before beginning the dimensional analysis. Now that I have a map for solving this question and everything's planned out, that thought process is complete. Let me calculate the molar mass for CH4, 1 carbon, 4 hydrogens, 1 carbon, 4 hydrogens, so that I have all my equivalent statements ready to go. Time for the dimensional analysis setup. The problem gave me 2.4 liters of methane. I know this is a 2-step process, so I put in both fraction bars, 1 for each step. My first step is to change liters to grams. And the second step, I'll convert grams into moles. Notice, units first, all the way through. Now the numbers. In the density equivalent statement, the 1 is next to the liter and 0.76 is next to the G. All I ever do in this step is match what's in those equivalent statements. The molar mass is the grams in 1 mole, 1 on the top, and that on the bottom. Now plug it in. 2.4 times 0.716 divided by 16.042, and I get that with a few guard digits. I've spent more time on this than any other question so far. It's more important than ever to run my check. My process changed liters to grams to moles. So I found moles of CH4. The question asked me to find the moles of methane. Nice. I did what I was supposed to do. The 2-step conversion was definitely unique in comparison to the other problems in this video, but notice that the process was exactly the same. Learn the process. Build your habits. Here's the thing I want you to walk away with. Dimensional analysis is a process for performing conversions throughout AP Chemistry. You need to be familiar enough with this process to identify when to use it and how to apply it in a wide variety of conversions. It's only a single tool in your kit, but it is the most commonly used. Throughout my videos, I'll continuously come back to apply dimensional analysis for solving future problems. I've guided you through a few problems here, but that's not enough for you to be able to implement this process at the AP level. Don't just watch the chemistry, make sure you go and do the practice. Thank you for watching. If you found this video useful, please hit the subscribe button. It really helps me out and it'll allow me to keep making better and better content to help students like you. Thank you very much for your support, and I wish you the best of luck in your studies.